Okay, hello guys. This is the AMS practice quiz for our upcoming CA on Thursday this week. Okay, so look, in this first question, when you have equals to like a fraction and that equals to 0, and the numerator and denominator do not have any common factors, we could just forget about the denominator. So forget this ever even existed. We get x minus 5 equals to 0. Okay, so let's focus on x outside the bracket. When something is outside the bracket, it is distributed to what's inside the bracket, so it's multiplied. Like whatever is inside the bracket is multiplied by whatever is outside. So the only number that when it is multiplied by, like, the only number that could change a number like a constant number, look, wait, I don't know what I'm saying. The only number that when it is multiplied by a constant number that could equal 0 is obviously 0. Like, that's common sense, we all know this. Like, negative 5 multiplied by 0 is 0, 4 multiplied by 0 is 0, 2 multiplied by 0 is 0, you get the point, so on. So whenever you have an x outside the bracket, just know that one solution to equals to 0 will definitely be x equals to 0. Now let's focus on what's inside the bracket. We have x minus 5. Let's forget about the x. Thought about this. Bad. So forget about the x over here. We have x minus 5 equals to 0. We take negative 5 to the other side, it becomes plus 5. So we have x equals to 5, and that is the second solution. So the final answers are x equals to 0, because whenever you have an x outside, as it is over here, whenever you have an x outside the brackets, just know that 0 is always going to be the solution. It's common sense. And then focus on what's inside the bracket. Take the constant to the other side, as we did here. Minus 5 changes to plus 5, so x equals to 5. So x equals to 0 and x equals to 5 are the two values that satisfy this equation. Okay, here we have, like, as we said, only cancel out, forget about the denominator when there are no common factors between the numerator and denominator. Here we have x minus 3 in the numerator and x minus 3 in the denominator. We could cancel that out, so we'll get x minus 7 over x minus 5 is equal to 0. We have no more common factors, so we could just forget about the denominator, as we said in the previous question. So we have x minus 7 is equal to 0. Let's write that down over here. We could take negative 7 to the other side. It changes to positive 7. So we get x is equal to 7. This one is an easy question. It's just like the first one. Here, given n is equal to 9 squared, which of the following are the square roots of n? Okay, so 9 squared is basically just 9 times 9. So that will equal to 81. So n is equal to 81. And they want the square root of that. So this is like common sense. This is easy square roots. Like, we learned this in grade, I think, 6. Negative 9 multiplied by negative 9 is positive 81. and positive 9 multiplied by positive 9 is 81 too. Positive 81. So the two square roots are 9 and negative 9. I think this is lesson grade 6. Alright. Given n is equal to radical 64, which of the following is true? Okay, here when it says radical of a number, like here it says 64, they're only like the answer should only be the positive root. You can't write the like negative root. Like that's just the rule. Like when they like you only give the negative root when they ask for the square root and they don't ask for the radical sign. But here they put the radical sign. You have to only put the positive root. So radical 64, that's also like, as we said, we learned this in grade 6 I think. This will be just 8 multiplied by 8, which is 64. But as I said, like, even though negative 8 multiplied by negative 8 is also 64, you can't, like, that's not an answer because of the radical sign. Like, you can only put negative 8 when they're asking for what are the square roots. That's when you put negative 8 and positive 8. But when they're just saying radical 64, you only put the positive root, which is just 8. So n is equal to 8. Which of the following is equal to negative sign outside the radical 81? Okay, so here we just focus on what's inside the radical first. Radical 81, this was literally like question 3. This is just 9 multiplied by 9. As we said, when they put the radical sign, you only put the positive root. So we get 9 over here. And then since there's a negative sign on the outside, we add negative to the answer. So negative 9. So we just focus on what's inside the radical first. 81. Radical 81 is 9. We learned this in grade 6, as I said, multiple times. And since it's only also I explained this in the other question. When they ask like only for the radical, you only put the positive root, so it's just 9. And then negative sign on the outside, that carries into the answer, which is going to be negative 9. So negative 9 only. Here, which of the following is equal to radical negative 49x squared? Okay, so when you have a radical, and inside that radical, it's a negative constant, and then squared, what you do is you cancel the squared and you cancel the radical and you change the negative sign to a plus. This is just the rule. When you get a radical and inside that radical you have a negative constant and a squared, you cancel out the squared as we did here and you change the negative sign to a plus. So we will get 49x. Okay, and now after we got 49x, like you see these, like, let me just show you how do I explain this. So there are like these two lines, they're called absolute value. This you only you add it when you have a variable like x over here, like for example x, y, z, they're all variables, and that variable has a odd exponent. Like here this is just x, which is basically x to the power of 1, that's an odd exponent. Like x to the power of 3, that's an odd exponent. X to the power of 5, that's an odd exponent. So you add the absolute value over here to the answer. So your final answer will be 49x. 49, and then the x is in the absolute value, because as I said, you add this when the variable has an odd exponent. 1, 3, 5, 7, 9. They're all odd numbers. Okay, in the diagram below, M and K is similar to triangle XYZ. MS is equal to 35, NL is equal to 25, okay, and XR is equal to 14. So when you have similar triangles, actually let me zoom in. When you have similar triangles, you basically do the proportionality theorem, which is like MS is equal to XR. We have NL is equal to YF, and then so on. Like, let's say we could also do NK, even though this is useless for this question, is equal to YZ. This is just the proportionality theorem. Forget it for this question though. Okay, so we have the proportionality theorem, MS, which is 35, over what's XR, which is 14, is equal to NL, which is 25, over YF. We could just substitute YF with X to make the question easier. Okay, so now we could simplify. Divide the top and bottom by 7. This becomes 2. This becomes 5. And we will get 5 over 2. So we'll get 5 over 2 is equal to 25 over X. We could cross multiply. 25 multiplied by 2 is 50. 5 multiplied by X is 5X. So we do 50 divided by 5. 50 divided by 5, because we took 5 multiplied by X to the other side. That becomes 50 divided by 5 equals to X. Divide by 5 to the top and bottom, that will be 10 over 1. So X is equal to 10. So we just apply the proportionality theorem. MS, like you could draw on draw on the figure to make it easier. Like, you could write it on the paper. MS is equal to XR. It's just similarity. NL is equal to YF. You know, because they're similar triangles. So, and then we just do the proportionality theorem. MS 35 over XR 14 is equal to NL 25 over YF, which we just rebranded as X. And then we just simplify and then just cross multiply. So yeah, we get X is equal to 10. X, or then subtract X is, we just rebranded to YF, so YF is equal to 10. If you don't change it to X, that won't change anything. Like, just keep it as YF. If you get like confused, you don't have to change it to X. Okay, here 2x squared minus 18x. Here we do the greatest common factor, so we take 2x outside. Inside the bracket it will be x minus 9, and then x is equal to, okay, over x is equal to 0. Okay, look here, we could cancel out x from the top and bottom. We get 2, so yeah, now we just get the denominator out of the way. We get 2 x minus 9 is equal to 0. Okay, we could forget about the 2 because it's not gonna do us any help. So just look inside the bracket. We have x minus 9 take negative 9 to the other side. That changes into positive 9. So x is equal to positive 9, or x is just equal to 9. So yeah, x is equal to 9. Here, okay. 10 over x minus 5 plus 3 over x equals to 3 over x minus 5. So what we need to do here is have all of the fractions have the same denominator. Even this fraction over here, all of them need to have the same denominator. So we do x minus 5. No, wait. This one's already fine. We don't need to change it by anything. Plus 3 over x. We could multiply this fraction by x minus 5. So x minus 5 in the top, x minus 5 in the bottom. Distribute the 3. 3 multiplied by x is 3x. 3 multiplied by negative 5 is negative 15. So let's just change that. Over x minus 5 is equal to the final fraction over here. We just multiply it by the top and bottom by x, so they all could have the same denominator, which is x minus 5. So we get I need to okay, look, 3x over x minus 5. So they have the same denominator, x minus 5. I don't have enough space to write it. So look, now when they all have the same denominator, we could just cancel all of the denominators out. But they all need to have the same denominator in order for you to do this. That's why we got them all to have the same denominator. So now we just focus on the numerators. We'll get 10 plus 3x minus 15 equals to 3x. So 10 plus 3x minus 15 equals to 3x. Do standard form to make it easier. Take this to the start, and then we have 10 minus 15. So we get 3x plus 10 minus 15 equals to 3x. Positive 10 minus 15, change opposite. That will be minus 5. So we have 3x minus 5 is equal to 3x. Take the 3x to the other side, so we can have 0 on this side. So that will be 3x. It will be 3x minus 3x minus 5 is equal to 0. 3x minus 3x is 0x. Minus 5 is equal to 0. Okay. And then we just take now negative 5 to the other side. Since it's the constant, we'll have positive 5. So we'll have 0x is equal to positive 5. When you have 0x, that is like you can't divide by anything. You just have 0x is equal to 5. That's basically just nothing is equal to 5. So there's no such value. Like x has no value, so we can't do anything. So it's just like 999 because there's no value. Okay, so what we did for this question was basically just move around the equation. First, we just need to multiply the denominators so they could all have the same denominator. We cancel all of the denominators and we focus on the numerators. And then we just do the common algebraic equation. Okay, here, what integer is equal to radical negative 12 squared? As I said in the other question, when you have a radical and a negative constant and the squared, we cancel the squared, we cancel the radical, and change the negative into a positive. Okay, so yeah, so the answer is just positive 12. It's basically just it. Positive 12 is just 12. Okay, if LMN is similar to RST, then MLN is similar to box. Okay, so here we just need to rearrange the letters. So we have L. Let's draw the figure. MN is similar to RST. So we have LMN is similar to RST. Then MLN is similar to box. So MLN, we start from the left S, we go to the vertex R, and then we go to the right side T. So MLN is similar to to SRT. That's the answer. Because they said that LMN, we start from the vertex, go to the left side, and then end up in the right side, is similar to RST. We start at the vertex, go to the left side, and end up in the right side. So, and then they're asking for MLN. Start at the left side, go to the vertex, end up in the right side. Start in the left side, go to the vertex, end up in the right side. SRT. This one's a very simple question. Here, given polygon ABCD is similar to M and QP, what length is missing in AC over MQ is equal to BC over box? Okay, so for this question, let's draw out the figures. We have polygon ABCD. Start from the left, and then like you need to know the order to draw the figures. It has to be in the same order. Start from here, go to this side, go to this side, and then go to this side. It's similar to M and QP. Start from here, top right, bottom left. Okay, so what length is missing in AC over MQ equals to BC over box? So we have AC over MQ, and then we have BC box, that's just NQ. It's really just simple, yani. We drew out the figure. This is such a, like, if you get this wrong, then you need to start like focusing, because like this is literally just a similar polygon. Like AC, this is the what's it called, diagonal, is similar to diagonal MQ. Then BC is obviously similar to the right side, which is NQ. So what length is missing? It is NQ. Polygon ABCD is similar to KLMN. So here I don't think we need to draw the figure because this one's a really simple one. So A is wait. So we have A is, let me just draw it up. A is equal to 40 degrees. Since they are similar, then K is also going to be equal to 40 degrees, because A is the first in polygon ABCD, and K is the first in polygon KLMN. B is equal to 102 degrees. Then L is equal to 102 degrees because it's second. And then C is equal to 80 degrees, M is equal to 80 degrees, D is equal to 138 degrees, then N is equal to 138 degrees. It's that simple. So as we said, since B is second, then they're asking for L, so we just take the angle of B, the measure of the angle of B, which is 102 degrees, so L will be 102 degrees. Okay, given ABCH is similar to DEFK. Alright, let's draw out the figure. ABCH is similar to DEFK. DEFK. Okay, so AB is equal to 7. D is equal to 42. EF is equal to 66. then BC is equal to box. Let's just rename box as X. Okay, so this is the proportionality theorem, like literally. So AB, let's start with the first ABCH, since it's the first polygon. So we have 7, and then let's put DE's value, which is 42. This is just a similarity, proportionality theorem, as I said. And then we need to start off with the left one in the other fractions, since if we start off with 7. We can't just go with 7 and then start off in the second fraction with 66. And then we put 66 as the denominator. Okay, so we could simplify by 7 top and bottom. That will become 1 over 6. So then we have 1 over 6 is equal to x over 66. Cross multiply. That will be x multiplied by 6, that is 6x. 1 multiplied by 66 is 66. Take 6 to the other side, it becomes 66 over 6. So like x equals to 66 over 6. Divide the top and bottom by 6. That'll be 11 over 1. So x is equal to 11, also known as BC. I told you I just like renaming, like when they ask for the box, it's just easier for me to rename it to x. If that's confusing for you, just keep it as BC. Okay, LMN, they already drew out the figure, so this will be easy. LMN is similar to box by the box. Okay, so triangle LMN is similar to look. Okay, so here there is no angle drawn in angle M. There's no angle drawn, so we start off with V, since there's also no angle drawn over here. Then they go down to M, which has one line around it, one curvature. So T, VT. And then they go to N, which has 2 curvatures, which is U. So VTU. That's a pretty simple question. So LMN is similar to VTU. Now they're asking for the theorem or postulate. Okay, so look over here. Since they have drawn 2 angles, like these 2 lines are basically 2 angles, that is the AA postulate. When 2 angles in a triangle are when 2 similar triangles have when 2 triangles have congruent angles, they are similar. AA postulate states that. So, and they literally just drew the 2 lines over the 2 angles over here. Yani, what do you think these lines are? So they basically tell you there are 2 angles here and 2 angles here. So AA stands for angle 1 and angle 2. So AA postulate. Here for this one, this is the SS proportionality theorem. It states that 12 over 12 plus 4 equals to 9 over x. 12 over 12 plus 4, that will be 12 over 16, is equal to 9 over x. Divide by 4 up and down, that will be 3 over 4, equals to 9 over x. So 3 over 4 is equal to 9 over x. Cross multiply. We get 3 multiplied by x is 3x. 9 multiplied by 4 is 36. So we have 36 is equal to 3x. Take multiplied by 3 to the other side, that will be divided by 3. So we have 36 divided by 3 is equal to x. divide by 3 from the numerator and denominator, that will be 12 over 1. So 12 is equal to x. So basically this is, for this question, just the SSS theorem. Let's name this A, let's name this B, let's name this C, and let's name this like D and like E. Okay, so AB is over AC is equal to BE over CD. This is basically just the SSS theorem. Okay, so as we said, what's the value of x? That is 12. Because we do 12 over 12 plus 4, so 12 over 16, and then we simplify as we did. That would be 3 over 4 equals to 9 over x, and then we cross multiply. Okay, xyz is similar to srq. What must be the value of x to be? What must the value of x be for the two triangles to be similar by the SSS similarity theorem? Okay, so we do the similarity. We could do the proportionality theorem for this one. Okay, so they already drew out the figures and they put them like correct order. We have xy is similar to SR, so 6 over 3 is equal to, we could do yz over rq, which is just x. Divide by 3, that will be 2 over 1. So we have 2 over 1 is equal to 12 over x. Cross multiply. We get 2x is equal to 12. Take multiplied by 2 to the other side, it will become divided by 2. So we get x is equal to 12 divided by 2. Let me just write that, the new equation. X is equal to 12 over 2. Divide by 2 by the numerator and denominator, we will have 6 over 1. X is equal to 6. Okay, GH is equal to 54. Okay, so GH, the whole thing over here, is equal to 54. QV is equal to 63. FB is equal to 36. This is 36. And G is equal to 45. Where is G? G is over here. It's equal to 45. Okay. So, what is the length of PD? They want the length of PD. So, what we could do is just the proportionality theorem again. We take we need to take one side that's also there, like that also has a value in the other triangle. So this side, the base side in the first triangle has the value of 54, and the base in the second triangle has a value of 63. So we could use that. And then, as we said, the value of FB is 36, we wrote over here. And that is the similar side to PD over here from the second triangle. So we could do 54 over 63 is equal to FB, which is 36, over PD, or as I like to call it, X. Simplify, divide by here by 9, here by 9, you'll get 7 over 6 over 7, apologies. So 6 over 7 is equal to 36x. It's 36 over x. cross multiply 6 multiplied by x, 36 multiplied by 7. Or an easier way to do this, we could do actually never mind, that way we might confuse you guys. So 36 multiplied by 7, let's do the long multiplication. Place it like this. Alright, 36 multiplied by 7. 6 multiplied by 7 is 42. 3 multiplied by 7 is 21. Plus 4 is 25. So 6x is equal to 252. So we do 6 divided by 252 to get our answer. So let's do that. 252 divided by 6. Alright. 25 divided by 6, that will be the closest is 24, which is gonna be 6. No, not 6. 4. Sorry. 24. 1. Drop down the 2. 12 divided by 6 is 2, so we have 42. And then the remainder is 0, of course. So the answer is going to be 42. Do you guys understand why? Do you guys understand why? Because, like, look, GH is equal to 54. QV is 63. FB is 36. And G is 45. I mean, you could just forget about GA because it's useless. It won't give us any information. So just forget about GA and focus on 54, 63, 36, and yeah, because we forget about GA because look, FB is similar to side PD. Yani you could see that they have the same like they look alike. Like you understand when it's similar, like they just look alike. Like GA would be similar to QC, you know why? Because like they look alike. So we focus on 54 over 63 equals to 36 over PD, and then you just simplify and cross multiply. So yeah, we got the answer is 42. In the diagram below, M and K is similar to XYZ. MS is equal to 18. So MS is equal to 18. NK is equal to 45. NK is equal to 45, yep. YZ is equal to 10. And what do they want? I'm gonna... Okay, just focus on this right now. Don't forget this because I'm gonna need to scroll down. Okay, XR. Yeah, they want the value of XR. Okay, let's just rewrite that. 18, 45, YZ is 10, XR, yeah. Okay, so look, MS is similar to XR because I just told you in the other question, whatever looks alike, you also, like, you don't actually, you forget about whatever looks alike. Here it says MN is similar to XY. Take individual segments. NK over here is going to be similar to YZ. And we have MK is going to be similar to XZ. So yeah. And then you could use this like when they look alike and stuff, if you're like this is a simpler method. You could just use the stuff they gave you over here. Like divide them into individual segments. Like first angle is gonna be first angle is gonna be congruent to the is gonna be similar to the first angle on the second triangle and stuff like that. Yeah. So let's move on to the question. They want to find the value of XR. So we have 45, which is similar to the other base. So 45 of 10 is equal to 18 over xr, or just also known as x. Simplify, divide by 5 top and bottom, you will get 9 over 2 equals to 18 over x. So 9 over 2 equals to 18 over x. Cross multiply, you will get 9x is equal to 36. 36 divided by 9 is just 4. Divide by 9, top and bottom, 4, 1. As x is equal to 4. Yeah. So, wait. Yeah, actually. Here, okay. We could, this is clearly not like, arranged well. So, I think they told us these two are similar, yeah? Okay. What must the values of x be for the two terms to be similar by the SAS similarity theorem? SAS is when you have two sides that are similar and then one angle that is congruent between them. Yeah. Actually, yeah, that's right. Okay, so we have E is equal to 45 degrees, and clearly B is equal to 45 degrees. And then, like, match the shape, you know? Here you see that it's a straight line, here it's a straight line. So, like, flip it onto there. So, let's just arrange it correctly. We will get X, as we said, just arrange it. And then the base is gonna be 9. This is 18, by the way. So the base is gonna be 9. 45 degrees over here. And then 4. After we arrange it correctly. So we have 12 over x, because they're similar. 12 over x is similar to is equal to 8 over 4. This is the proportionality theorem. So divide by 4, you'll get 2 over 1. So 12 over x is equal to 2 over 1. Cross multiply, you'll get 12 is equal to 2x, which is 12 divided by 2, that is just 6. So x is 6. Okay, DE is equal to 15. 15. AB is equal to 6. CJ is equal to 10. And then FL. Okay, here it's obvious, like CJ looks like a median. And FL looks like a median. AB looks like a base. DE looks like a base. So we could clearly see that 15 over 6 is equal to FL is we could also just call that x, as I'd like to do, over 10. Simplify, divide by 3, top and bottom, you will get 5 over 2 is equal to x over 10. Cross multiply, you get 50 is equal to 2x, which is just take multiply by 2 to the other side, that will be 50 over 2, which is just 25. You guys know why. Alright, if PQ are similar to FED, then what is the value of A? Okay, again here you could just rearrange the triangle to make it look alike. So we have the base over here is like looks like to this base. This looks like to this. Yeah. So let's just rearrange it. We get R QP and 12 in the bottom, 5 over here, and then 13. Our proportionality theorem, we have 5 over 10, because look, this is proportional to this, but let's start with the one on the right, I don't know why, is similar to, is equal to 12 over A, proportionality theorem. Okay, divide by 5 top and bottom, you get 1 over 2 is equal to 12 over A. Cross multiply, A is equal to 24, because A is equal to 12 multiplied by 2, which is 24. Yeah. Yeah, okay, and everything is correct. Okay guys, I'm sorry this video took so long. I was just explaining everything in detail to like make you guys understand better and understand why everything is like, you know, how it is. If you want the videos to be shorter, you could just tell me so, if like you want me to explain less details, or if you just want it like this, that's also fine. Alright guys, thank you.